Before you can measure flavor compounds accurately, you need calibration standards. These are reference solutions with known concentrations that your GC uses to compare samples and to generate a calibration curve. In this video, I'm going to show you how to make a simple set of standards step by step. And you're only going to need a few basic things. On the consumable side, you're going to need laboratory grade standards for the flavor compounds you want to measure. These are things like esters, aldehydes, and higher alcohols. You're going to need deionized or distilled water, or some other suitable solvent that's going to depend on the compound. And you'll need some vials or flasks for storing the standards. For general lab equipment, you're going to need clean flasks or volumetric flasks, adjustable pipettes with tips for precise measurements, and labels and a marker just to help keep everything organized. And on the gas chromatography side, you're going to need a gas chromatograph with an FID detector. This is a flame ionization detector, and here we use a compact Ellutia 200 series GC. Now, this method that you would run for this is with an injector temperature of 250 degrees C, has a short splitless injection time, and an oven program that starts at 50 degrees C and gradually ramps up to 220 degrees C. We use hydrogen as a carrier gas, and detection is by FID. Now, range switching is applied during the ethanol peak so that the trace flavor compounds can still be measured accurately. Now, let's get those standards made. We're going to start by preparing 1,000 ppm stock solution of each compound that we're going to be using in our chosen solvent. Now, this solvent could be deionized water or some other suitable solvent that's going to depend on the compound. We're going to mix this carefully so that it's completely uniform. This is the starting point for all the dilutions. From this stock, we can make 100 ppm by taking 1 ml and adding it into 9 ml of our solvent. Now, we're going to take 1 ml from that 100, mix that into 9 ml of solvent, and now we've got 10 ppm. From here, we can step down even further. To make 5 ppm, we're going to take 5 ml from that 10 and mix it with 5 ml of solvent. To make 1 ppm, we'll take 1 ml from the 10 and mix that into 9 ml of solvent. And now we can step down again. From that 5, we can make 0.5 by taking 1 ml and putting it in with 9 ml of solvent. From the 1, we can make 0.1 the exact same way. And now from that 0.5, we can make 0.05. And finally, from that 0.1, we can make 0.01, all the same way. Now, each solution should go into its own clean, clearly labeled vial, and everything's ready for analysis. Now, a few quick tips though. Always use a new pipette tip for every transfer. Make each dilution in a new, fresh container, and mix gently but thoroughly and keep everything accurate. And that's it. With just your standards, some solvent, and a bit of care, you've created all the standard sets that you'll need to form your calibration curve. Now, that calibration curve is what your GC relies on to give your flavor compounds accurate measurements. And that's going to give you reliable data on all the esters, aldehydes, and higher alcohols that define the aroma and taste. Now, if you found this useful, please give the video a like and subscribe for more. And let me know in the comments what other lab prep steps you'd like to see. Thanks for watching.